So I would like to take over and talk a little bit about GIST, building on both what Dylan and Pell have been talking about. I want to bring in some of the things of the history of GIST that will be helpful to nuance perhaps some of the things that Pell has been describing. And the other thing is that I would like this to whet your appetite for the next session on GIST, which will provide you with a lot more detail. We've already mentioned that there are a lot of upper ontologies out there. Here are some statistics, some vital statistics on a few of the ontologies. We've got GIST version 13. We've got the basic formal ontology 2020, Dolce Light, and the merged version of the common ontologies, CCO. And we see immediately on the class count, there are some very, very significant differences between them. Why is class count important? Well, one of the things that's relevant is the sort of cognitive load. How long is it going to take you to become expert in this? Not only the class count, but also the object properties and the data type properties. So you begin to wonder, well, why are there upper level ontologies with no data type properties? The next thing is equivalent classes. Why are equivalent classes important? Well, when we were looking at Frank the dog, it was an instance of dog, which was a subclass of mammal. But maybe if we didn't know what a mammal was, we wouldn't be able to assign dog to it. And we wouldn't know where to put our poor Frank. If, on the other hand, we knew that there was an equivalent class for dog that was something that had got a number of attributes, had fur, went bark, had a very, very friendly disposition, generally speaking, but could bare its teeth, then what we could do is we could say, well, that looks like Frank, so maybe Frank's a dog. So equivalent classes are very important to help us infer something into a class. Similarly, disjoints are really important to have in ontologies. And when disjoints are missing in ontologies, you begin to wonder, well, is every class there really somehow the same, or are there real distinctions between them? So when we've started taking a look at these ontologies, I want to focus on GIST here, which is version 13. So where has GIST gone to get to version 13? We can take a look at the next slide, Dylan. What we see here is different aspects of GIST over the past, oh goodness knows, 30 odd versions since something back in 2009. And there are several things that are noticeable from this. One of the things is that we already start with a reasonable number of classes and object properties, not that many data type properties. But generally speaking, over all the versions, it's pretty consistent, somewhere in the order of, what, 100 to 130 or so classes. So let's dig into this and see what's been going on. There are a whole number of things that appeared throughout all of those versions. What you'll see in some of these slides are a matrix. When it's filled with green, it occurred all the time. And when there's white spots, that means that it wasn't there in that particular version. And things that were there throughout these 30 versions were things like address, agreement, building, category. And if we look at how those are all linked together, we're not bothered about the detail, but just taking a look, there is lots of interconnection between things in that network diagram to the right. So what we find is that throughout GIST, from its earliest days to version 13, there have been certain classes that have been consistent and with plenty of links between them. Moving on, what we see are things that did change. Some things got removed, other things were introduced. Now, this takes us back to what Dylan was talking about in the way in which, as we use language, we modify it for the changing world. And what we also become is more expert in using it. And so we change our vocabulary a little bit. We alter the way in which we construct sentences and things like that. And so I've dug out a few illustrations of things like fizzgig and pettifogging that we don't really know, don't really use these days, whereas there are newer things that some people might be aware of now. They're not fully into the vocabulary, but things like a boop or a chef's kiss are things that are coming into the vocabulary. And so it is with a well-managed ontology, one that's used a lot, one that is regularly reviewed and updated, that there will be some things that get removed, other things will get introduced as the needs arise. And so when we look at GIST, what sort of things happened? Well, we began to get an economy of properties by removing the inverses. We found ways over the years of improving our modeling of units of measure and magnitudes and addresses. We applied more rigorous conventions when it came to naming object properties. And what we also did was move away from the corporate-based namespace to a W3 ID in order to get longer-term sustainability of the ontology. Remember that this GIST core is available on CC4, and everybody can use it. Equally, the community that gets involved in the changes that we've been looking at is quite wide, and many people contribute to the development of GIST, whilst Semantic Arts deals with the governance and the release of different versions. So I've already mentioned before the importance of equivalent classes. It's something that I mentioned in the context of a dog, and here we have something about it in context of a cat. But equivalent classes are very, very helpful in enabling people to get to grips with an ontology quickly. It helps to have, in addition to the textual definitions, equivalent classes. It helps people improve their modeling skills. And so we find, because we're moving into enterprises that perhaps aren't familiar with using ontologies, and we are taking an apprenticeship approach towards our work with our colleagues, that having things like equivalent classes help them come up to speed much more speedily than would otherwise be the case. Properties are extremely important in ontologies, and as we've seen in the earlier table, sometimes upper-level ontologies are a little bit deficient on providing properties. The other thing, of course, is that they're important from the perspective of defining equivalent classes. And what's curious about classes and links is the many centuries that went by before we actually moved from purely focusing on classes to looking at links. So when you are taking a look at upper level ontologies, definitely consider the sorts of predicates that are available to you and the ways in which those might be used in order to give you some sense of equivalent class. Having said that, in the illustration that I provide, it's almost entirely OWL properties that have been used, but it is useful to have a fair vocabulary. So I want to close off this presentation and move on to the discussion, if we've got any time, by saying that when you're looking at any ontology, check that it is actively maintained and up to date. Take a look that it hits the Goldilocks level of abstraction. Make sure that you've got definitions in natural language for everything. Make sure that there is not only a taxonomic hierarchy of classes, but also pay attention to properties, including things like disjoints and so on, and that there has been some use of equivalent classes to enable you to infer things into a class and to help you better define the class entities that you have within the ontology. And I think that takes us to the end of our presentation.